I'd like to introduce Andrew J. Hampton. He's Assistant Professor of Psychology at Christian Brothers University and the Chair of IEEE Standards Association Working Group for Adaptive Instructional Systems. He's an experienced researcher with demonstrated history of working in the higher education industry. He's skilled in education technology, psycholinguistics, research design, leadership, and classroom instruction. Strong research training with an MS and a PhD focused in human factor psychology from Wright State University and a postdoctoral research fellowship under Professor Art Grasser at the University of Memphis. Thank you so much, Andrew, for being here this evening.
Thank you very much. I'm excited to be here.
All right, I'm going to pop over to introduce, oops, I went the wrong direction, guys, sorry. And lastly, last but not least, I'd like to introduce Phil Horowitz, Chief Architect at JBS Custom Software Solutions. Phil is Chief Architect at JBS Custom Software Solutions, an industry veteran with over 20 years of experience. Phil has designed and developed systems in a variety of areas: education, defense, healthcare, retail, and financial service industries, to name just a few. He has extensive experience in modernizing, building, and integrating complex systems for the education sector. Phil is currently the lead architect for the online educational publishing and digital learning platform for one of the largest nonprofit edtechs in the world, helping establish a new set of processes, technologies, and infrastructure initiatives to deliver solutions that are scalable for future and future-proofed. Thank you, Phil, for being here this evening.
Thank you. Great to be here.
All right, so I'm going to go ahead and turn over the presentation to Ed, and we'll get the discussion started. Anyone in the audience that just joined, please know that you can issue your questions in the chat during the presentation, but we will also have time at the end for a live Q&A session.
Okay, so I thought we'd kind of start with Drew and see if he would give us a sort of general baseline primer on machine learning. What is it, and how do you see it being used in education?
Sure. So I'd like to illustrate a little bit. So I've been working in developing a handful of adaptive instructional systems throughout my career. And probably the most complex one that I've worked on, I'd like to show you just a little bit about that, how we did that in the old days of 2016 to illustrate what we can accomplish with machine learning, and also where we're very likely to run into problems. So the task with Electronics Tutor was really to take a whole bunch of different independently developed learning resources and put them all together into a single interface that was going to utilize all of these efficiently. So the challenge was pretty substantial. We had Auto Tutor that was built out of University of Memphis, where I was at the time, and we were in charge of this integration, a conversational interaction between artificial agents and a human learner. Then the only thing we were starting with was the Navy's manuals for electrical engineering, which is basically like 4,000 pages of very, very dry documentation and standards. This is about as exciting as it gets, these pages here. Then there's out of, again, the US Navy, they had developed this conversational tutor as well, but at a different kind of level of analysis. Out of BB&N Raytheon, they had these really cool interactive step-by-step formulaic problems to help make sure that people could do the calculations correctly. Assessments out of Worcester Polytechnic Institute, trying to make it easier for the instructors to add more content and to see more granular progress on different questions. Then out of Arizona State, this really complicated but very comprehensive and impressive tool where you could change one part of a dynamic system and see how those changes would be propagated throughout the system. And then finally, we had Point and Query, again, out of Memphis, where you could interact with diagrams, lowering kind of the barrier for engaging with the material. So putting all of these together was this massive challenge to figure out how can we get independently developed systems to talk to each other and have meaningful information about a learner conveyed with a high degree of fidelity. And more than that, how can we implement artificial intelligence to say this is the thing that this particular student should learn next? So the way that we did it, again, this is before we had like the kind of machine learning capability at Memphis, is we basically brute forced it. We said, okay, there's 15 different topics that we're studying. Each one of these is going to be either a device or a circuit. It's also going to be either a structure, a behavior, a function, or a parameter. And then we just multiply those things together, and we wind up with 120 different kind of tags that we can put on each of these different questions, each of these problems. Then we have, well, working with domain experts, we say, what order should these generally go in? How many of these different kinds of problems should they tick off so that we can get a pretty good estimation of their mastery of a topic? So we're taking a ton of expertise, a ton of time, a ton of brute force to try to get these data in a meaningful format so we can make a reasonable recommendation of what a student should do next. And it wound up looking like this at the end of the day, where it's just one interface, but it's going to jump between all of these different systems. So that's essentially the goal, is to have one interface and a whole bunch of things working in the back end that are going to let the user experience a natural flow from one thing to the next that's going to be intelligently informed. Now, if we, I'm going to stop share. If we're to leverage machine learning, which people are starting to do now, and in certain applications, it's pretty far advanced, instead of having all of those experts predefined, this is the progression that's ideal through the learning environment, we can just tag all of these data, throw them into a model that's completely naive. It doesn't have to know anything about the particular domain. And then it's just going to look with which of these patterns that either people just chose without any kind of guidance whatsoever, or it can evaluate what did an instructor's recommendations do in terms of speed of progress, efficiency of progress, and it can look at whatever your outcome variables are and figure out which of these patterns, which of these connections are strongest, are most predictive of success. And without you doing anything, generally an unsupervised approach, it's going to say, these are the fine-tuned ways that are proven to be most effective to move through this educational environment. So that one application has been tried in a whole lot of different areas to try to see just what happens if we throw a lot of data at this problem and just let the machine learn what are the efficient connections and how can we optimize this system to do better than what a human rater is capable of processing at any given time. The most expert person in the world is going to be limited by just how much information they can hold in their head at any given time. So we wind up having to rely on logic, on rationality that isn't necessarily based on empirical fact. It's based on what we think should work, or it's based on theory that's been tested in different applications, but it's not particular to this application. So machine learning is potentially a massive step forward in terms of ensuring and testing efficiency in these massively complex systems.
Wow. So would you say that that's working right now? Are EdTechs using similar processes as what you described, or is it really an opportunity to embrace a new way of doing things?
So I've seen this from a couple of different perspectives. I've worked in the EdTech field, and I'm on a grant with the National Science Foundation called the Learner Data Institute, where they're just trying to come up with a whole bunch of different ways that this could work. What can we do? How can we get data that's not just from EdTech, but like from classrooms where conventional learning is taking place? And yeah, there's a lot of ideas that are flying around right now. To the extent that it's actually in use, it is much more in the private sector. So when I'm working with the IEEE group on standards for adaptive instructional systems, we'll see people are implementing machine learning, but it's going to be kind of very siloed. They're doing their own thing to try to gain a market advantage, and they're not necessarily sharing what's working or best practices beyond sort of abstract, this is what I think would be beneficial to the environment as a whole, to the market as a whole.
Gotcha. So can you talk a little bit about the different forms of bias?
Yeah, so with all of this tremendous opportunity, with this incredible power, it's very important to recognize that the machine learning algorithms are completely naive. If we don't do anything about it, they are going to find patterns, including patterns that we don't think are appropriate. So for example, if they want to predict which students are going to do the best on an assessment, then that's probably going to be really highly correlated. They're going to be very predictive based on things that we would like not to count. So like things like their race, things like their socioeconomic status that are predictive of performance, because the kids who are higher socioeconomic status are in better schools. And then they're kind of compounding that advantage that they already have by this naive system who doesn't know anything about race, doesn't know anything about socioeconomic concerns, is just saying, based on the data alone, these are the kids that are doing the best. And then they're going to kind of copy and paste, this is the pattern that I've recognized, and I'm going to use that approach that seems to be doing well in these other situations, these other economic or racially diverse areas that it wasn't trained on. So it's not aware of any of these problems that we recognize societally bias exists. So it's potentially going to perpetuate those existing biases unless we do something to recognize that and consciously counteract.
I was going to ask about that. Like, how can you, even if you identify how do you correct for it without like undoing the indicative nature of the machine learning?
Yeah, so this is what we're dealing with. This is the primary question: is how do we consciously counteract biases that are built into a larger system, a system that's outside of the confines of a machine learning algorithm. So you'd think, okay, we just take out information about their race, take out information about their socioeconomic status, take out information about their gender. The problem is that the machine learning algorithm is so powerful, we have what's called the reconstruction problem. That based on data that superficially, to our eyes, would have nothing to do with any of those protected classes, it can infer these things. And even more than that, it's not even bothering to infer them because it doesn't know that that thing is important. But if our socioeconomic status, our race, our gender, our sexuality, any of these things is for some reason contributing to what look like benign factors that the machine has access to, that it can learn from, then it can, again, reconstruct without even knowing it's doing it, those biases and perpetuate them on down the line.
Wow. Well, let's throw something out to Phil, talking about the practical examples in actual environments. And you're going to talk a little bit about how bias was handled in those environments.
Sure. So as someone who's led multiple teams in machine learning initiatives at a very, very large ed tech nonprofit firm, I've seen a variety of different kinds of issues that teams have had when going to implement solutions like this. And Drew touched on a couple of important things about specifically how demographics are handled in our data set, and how the algorithms themselves, while powerful, are still naive. And ML algorithms, more so than traditional computer science algorithms, are really, really dependent on the quality and the fairness and the treatment of the data before it gets fed into the algorithm. And most issues that I've seen, of which some of these are actually quite interesting. One, for example, was a system that wanted to predict essay scores based on writing samples, based on history of writing samples. There are multiple commercial systems like this available now in their infancy, and there are many initiatives in many edutech companies that are trying to build similar products. One that was being built by a team that I worked with, one of the typical things in machine learning that you do is you split your data into training and testing sets. And a lot of people don't pay as much attention as they should into the actual kinds of data that go both in the training and in the testing. They have their data set and they might have done some cleanup, some prep, a little bit of feature engineering, whatnot, and then they say, okay, we're going to split it and let's go. And that is what this team did. And the issue was, though, the student samples of the same students were in both the training and the testing data. So you had student X essays in the training data. You also had student X essays in the testing data. So what happened was you essentially trained the model to look for how student X writes. So it can recognize student X. And when seeing and working with a different student, the model kind of fell apart because it wasn't trained to be able to predict and infer from new students' data that it saw. And that's a case of something that we call overfitting. But the way that we fixed that was we made sure that students that were when we split the data into training and testing sets, we made sure that students that were in the training set were not in the testing set or validation set. So it was constantly testing on student essays that it never saw in the training. And that was one of the ways that we handled that. There was another case where one of the demographic data points in this specific data set was state. So we were trying to predict test scores and how well students would do on tests. And one of the categories that they wanted to break it down was state. The problem was certain states, they had such a small amount of data. And in one state in particular, what happened was the representative samples from that state, which was an unusually small class of relative compared to all the other classes in that data set, all had poorly performing test takers for whatever reason. So all their model learned was that people from state X didn't do so well on tests. And that was, there were a lot of issues with that. And it took a little while to figure out what exactly was going on. And all these issues came down to the data, not the model. Not to say that ML algorithms and models don't have their own set of issues, but when we talk a lot about bias and fairness, really the heart of the matter is the data that you're working with. And I'll throw one more example out there was language. So this is actually not in edutech per se, but this was another machine learning team that I was working with. We were tracking sentiment for a large corporation based on social media content. And based on the data set, it turned out that we were tracking multiple languages. We were tracking this across English, Spanish, French, German, and so on and so forth. But again, because of bias in the data and not paying careful attention to how distributed the records were amongst the different languages, our model learned that anything that was coming across in German always had a negative sentiment. So it learned that it learned to associate negative sentiment with the German language, and then it used the German language as the indicator to determine negative sentiment, which is not how you want your models to learn at all. So in finding these kinds of situations, there's a lot of different ways a lot of different things that we can do in our data ingestion and our data preparation and our feature engineering that we can do to try to mitigate as much of the bias in our data sets as we can. And all this happens before any real quote unquote machine learning takes place. There are traditional techniques that come from statistics, and two big ones that you hear quite a bit about are undersampling and oversampling. And what undersampling and oversampling do, respectively, is when you have a data set, and a perfect example of this is a data set that might do fraud detection. If I have a data set of 1 million records and I'm trying to detect fraud, chances are the minority case are going to be positive in the sense that, yes, this transaction was fraudulent. And it might be 1 in every 50,000 or 1 in every couple 100,000 that you have a true positive for a fraudulent case, compared to the hundreds of thousands of negative cases that we have. So we have this incredible disparity in between one class of data, the non-fraud, and the other class of data, the positive class, the fraudulent classes. So what we can do with undersampling and oversampling is we can either remove remove some of the non-fraudulent cases in order to bring the numbers, the amount of records between the two classes that we're looking at have a little bit more equality. Or we can go the other way and we can add more cases of the minority case, in this case, the true positive fraudulent cases. So we have a similar amount of true positives and true negatives of those two different classes in our data sets. And that's very important, because when you have a data set like that has such an incredible biased viewpoint of one particular case, when we use that to train our models, they're not going to work. And one particular way of looking at this is that in this particular case with fraud detection, if I have 1 out of every 100 records is a fraudulent record, I could actually build a model that just hard codes, has hard-coded logic to never detect fraudulent activity, kind of as like a thought experiment. And in 1,000 records, my model is still going to be 90% accurate. So even though my model is completely wrong, it's still going to have a very high degree of accuracy. So it's very important that we're aware of some of these things when we go into preparing our data sets, and when not only preparing our data sets, but after our models are in production, that we actually use the correct metrics to measure the models that are in production, to make sure that the predictions and the inference that they're doing are measuring the outcomes that, our goals, that they're aligning with the goals that we want these models to perform for us. So the techniques that are coming from traditional statistics that's one branch of them. And then I'm going to talk about 2 more that had their roots there, but have come from a much more sophisticated mathematics area, and one usually actually even incorporates machine learning itself. So one is called SMOTE, and SMOTE it's an acronym, and it stands for Synthetic Minority Oversampling Technique. And what SMOTE does is SMOTE intelligently creates additional data to augment the minority class in a data set. And it does it very intelligently by looking at the existing minority samples and then using some more sophisticated algorithms to generate similar data. So we have a much less disparity in the numbers between one class versus another class. And then much more, I would say, probably on the cutting edge today is something called GANs. And that's another acronym, and that stands for General Adversarial Networks. And what they do is they use deep learning. They use neural networks. It's a technique that uses 2 different neural networks, and they kind of fight each other to generate the most realistic kind of data possible to, again, augment data where there's a large disparity between the numbers of positive cases and the number of negative cases. And I know that was quite a mouthful, so I go on much longer, but I'll stop there.
I do want to point, you made an important distinction when you talked about the 90% accurate model. So formally, there are 3 ways that this can go wrong, and none of them is actually in the machine learning. ML bias is a misnomer because machine learning is perfectly unbiased. The bias happens either before or after it. So you've talked a lot about the statistical preparations, how we can make sure the data are as unbiased as possible, but also the interpretation. And that can sometimes be even harder because when you're pulling data together, you understand I am intentionally trying to de-bias these data. But then we have this problem where we just trust automation. If this super intelligent machine learning algorithm has kicked out an answer, okay, great, I'm on board. And we are very quick, we humans are very quick to just sort of accept that automated things are correct. We're too quick. So we have to be especially cautious at that point. So I mentioned 3. The first one is actually before the data preparation, where, and this is potentially the least tractable problem, most of the time the people who are worried about this look like us. You know, it's predominantly male, it's predominantly white, and we don't have the kind of diversity on the teams that are putting these systems together that are sort of inherently trained in recognizing this bias. So making people aware who are practitioners, who are professionals in this field, that these issues exist. And to a large degree, that's what we're trying to do here, is to let people know these are problems we know exist. These are ways that we know we can mitigate them. But recognizing those 3 levels in the composition of the team, in the structuring of the data, and in the interpretation of the results, we can and do make mistakes at all 3 of those levels.
Can you talk a little bit more about things that were on the backside, the interpretation, like an anecdote about how something went wrong, either you or Phil?
So this has been done in the judicial system, actually. So we have recognized for a long time racial disparities in sentencing guidelines. So there was an attempt to implement machine learning and to fix that, to mitigate human error, human bias in discrepant sentencing. And this kind of thing happened that we've been talking about, where it recognized things that weren't explicitly put into the data set. It reconstructed those racial biases, but then we just said, well, you know, it was a colorblind analysis, so that's the answer. And we had to kind of hit the brakes and in fact go in reverse and say, okay, well, we tried that, but we need to do some more work because this is having very real, very negative consequences to people that we were trying to help.
I had seen a news article about that scenario, and it's like, the best intentions, and it actually put forward the exact opposite result that they were shooting for. Such is technology. Phil, did you want to comment on that?
Yeah, there's actually quite a bit of cases where there's been through the best intention, the models were just delivering god awful results, and we're creating more problems than helping solve them. One big one that comes to mind is facial recognition. Facial, it's something, for good or for bad, facial recognition technology is something that's becoming more and more popular, and it is being adopted with a very steadily increased usage rate. And the big issue with the facial recognition areas is it's not that the algorithms themselves don't work, because they do, and they can be very accurate. The problem is, in many cases, the libraries of training data that we use turn out to be nothing that the camera or that the video is going to see in production. So, for example, as Andrew said, a lot of people who engineered this stuff look like him and I. They're white, male, and unfortunately, many facial recognition training data sets reflect that bias. And as a result, in many cases, systems had to be shelved because people of color, different gender, different other different demographic data points were essentially creating highly undesirable results for the models that were deployed. And it was getting people into trouble in many cases. And that was actually a really strong object lesson. Sometimes, sometimes it's more or less harmless. It's something as simple as, oh, well, we need more training data that shows faces at a certain angle because the camera may be angled a specific way, and the training data, all the faces were 90 degrees, and they needed a more 45 or whatever, which no big deal. But then it could get a lot more insidious, where we're implying people are more prone to commit crimes and other scenarios that have real serious kinds of ramification if we're not aggressively conscientious and aware of the kinds of data that we are using to train these systems, because ultimately these systems are going to go into a production environment. They are there to solve problems, and people are paying money for this. And these real world problems can have some very real world ramifications if we approach implementing these solutions very naively.
Yeah, I think there's a lot to that. There's speaking of the facial recognition stuff, there's some real ethical, issues with using it, especially as people design things and they don't know what the people in the end are going to use them for, like what was done in China with using it to monitor minority populations. And the college professors that made that great system had no idea that that was going to be the end factor of it. I wanted to kind of touch on, how you're seeing this stuff show up in education tools. Is there a way to commercialize the data, make sure something's responsibly sourced? I don't know if that's like a good housekeeping seal of approval on data that has been put out.
So we've made some efforts at the standards level to try to say these are the best practices to ensure that we are being ethically responsible in sourcing our data. Commercialization of student data is this hugely sticky legal and ethical area because how minors are learning, how they are going about learning, calculus or history or whatever, is valuable data. They are producing valuable data, and they're not the ones profiting from it. So we don't, culturally, societally, we don't have an answer for what is going to be the best practice for that going forward, except to recognize that doesn't quite seem right. So especially right now, the data are really in the hands of whatever ed tech company has put their product forward and been adopted. And it's really not clear how that's going to progress forward. How we can mitigate these problems is really just to try to create a reasonable standard, and then create the kind of public pressure to have companies adopt that, or better, to create market circumstances where it's in everybody's best interest for them to adopt it.
Want to comment on that?
I'm sorry, Ed, I couldn't hear that.
Did you want to comment on that?
Yeah. So, I mean, everything Drew said, 100%. And I think even more so in terms of awareness and ethics, more so for the people that are actually implementing these systems, and the engineers and the data scientists, and whether it's people in industry or people in academia. Kind of like, as I was saying earlier, that aggressive awareness of the ethical implications of the systems that you are building. I think things are improving somewhat, and that knowledge is now becoming more explicit in terms of the kinds of things you need to look for in your data set. And there are tools now in terms of code frameworks and software services that are becoming almost every week now, that are being released with various degrees of success and efficacy, that people implementing these solutions can now leverage and use to help make sure that a lot of the kinds of naive approaches that were used in the past during the architecture and implementation of these systems are being mitigated. Now, things can't be mitigated 100%, but there's a lot of progress that really can be made based on the awareness and the level of education that our implementers have when building these systems.
Yeah, it's interesting. It almost, reminds me of like the early days of clinical research. Doctors did research studies in ways that would never occur today. And that stuff kind of went away by having a peer review of,
Right.
experiments and going, oh, well, you can't give certain people a disease to see whether they're going to respond to it anymore. And I wonder if that will occur if people are talking about that in the machine learning environment, like outside peer review of that sort of nature, like they would do for, scientific research.
So legislation is always going to follow behind the problem. And we sort of expect that, but what we can try to do now is to make sure the people who are decision makers, who are stakeholders, who are advocates for students are aware of these issues so that they can be on the lookout and push for more formal, potentially legislative resolutions that are meant to protect vulnerable populations, notably students and minorities. But I think it's really important to remember that we've been talking kind of doom and gloom, but this is an opportunity to radically democratize the best forms of education, where you won't need to live in the best neighborhoods and attend the best schools. You have internet access, and you can log in to systems that are going to very finely tune the way that you progress through any number of educational domains. So this opportunity is coming. It's essentially here, but we need to make sure that we're protecting both the data of the people and the best interests of them, especially once people come along and say, well, now that everybody has this advantage, how do I give my kid more of an advantage? How do I throw money at this problem and stop it from being a tiered system that's meant to, again, just benefit the people who are already advantaged?
Yeah, Phil, can you talk about some real world scenarios that have that positive, aspect to it for folks that have been traditionally left behind? How is this being used by companies in the ed tech world to do that very thing, that positive result?
Phil, that's probably your question.
Sure. Well, so there's a couple of things, and one of the biggest uses, this ties into one of the biggest uses of machine learning in ed tech, and that is developing proper curriculum and content regardless of our students' backgrounds, rich or poor, race, gender, what have you. And we can use these models to build adaptive systems to cater content to what's best for our students, regardless of where they are. And by using these kinds of systems, we could also find out areas of strengths and weakness, and we can mitigate and adapt and align our curriculums and our content accordingly. So whereas we have students that are excelling in one area or lagging behind, the systems can do what they can to try to even that out, so to speak, based on all the historical and real-time information that are getting fed into these systems that are allowing them to determine where help and support would best be needed and how it would best be utilized in terms of a particular group of students or a particular kind of assignments. It kind of goes both ways in that regard, where it's not just helping out students, it's also helping the other side of that as well in terms of what kinds of content and at the content level. I'm sorry, go ahead.
Before COVID, when we had these meetings in the real world, there was a panel discussion and this concept came up of like a tablet. It was like a personal Mr. Rogers. So a student would interact with it, and if that student was a visual learner, then the automatic Mr. Rogers would teach things visually. And if they were more, audio oriented, it would teach that. And it would keep like sort of teaching harder and harder stuff till it hit a wall. And then it would go back and reframe and what have you. And I'm like, it sounded like a far off concept at that point, but is that the type of thing that you're talking about, where it's actually adapting per individual's learning style?
So from the educational psychology perspective, we don't really use learning style. It turns out visual versus auditory, that kind of stuff is more preference than like actual performance. But yes, other than that, we're absolutely building systems that do that now. We try to stay in what's called the zone of proximal development. It's the question that you can almost answer, that you're almost there, and then we just give you a little bit of support, of help. And hopefully we build this self-reinforcing pattern of achievement, that you've accomplished something with minimal assistance that's at the edge of your ability, and then just keep doing that. So that's what we're trying to fine-tune largely with these personalized learning systems, with these avatars, for example, that will carry over across different subjects throughout the course or throughout your military training. I've seen that system that's in place in the Navy. So yes, that's not science fiction. That's not theoretical. That's being done. That's being prototyped, at least right now.
Well, from experience, I'm working on currently as we speak. I'm working with a team that is building that kind of smarts into an existing system right now. And some of it, certain bits and pieces of it are already in production, and other bits and pieces of it are currently in development. And it's very much a real thing, and it's very much in the real world. And for those of you in the K through 12, one of the big things that we're leveraging is a system called Learnosity, which is essentially an assessment creation and management tool. And we're using a lot of the historical data and work that's been done with that system into, which is a fairly static type system, and then building smarts on top of that for other companies that want to incorporate this into their overall learning management system. So yeah, it's very much a real world thing.
That is really interesting. There's, all sorts of applications I can see for that, both K-12 and in the professional world.
Yeah, a lot of it in our case is freeing up the educators to focus more on the content and focus more on the actual teaching than a lot of the boilerplate stuff that can easily either be automated or done via trained models and ML.
Cool. Well, we're coming to the 5:15 mark, and I thought it might be great to sort of open up the room and get the audience involved in some Q&A. So you guys good with that, or did you want to, were there any closing things that are like I really want to say this before we kick it into questions.
I did have one thing I wanted to mention, and that is an optimistic point to close on. Where we have seen bias in the past, it's really hard to nail down. So I mentioned the judicial system. We know that there's disproportionate sentencing for minorities. We know that that happens, and we've made it illegal, and it continues because you have to prove this particular case was discriminatory, and that's really, really hard to do. Unless the judge says, I did it because I wanted to discriminate, which they never do, you can't prove it. So the real benefit that we have here, the opportunity, is in accountability. If the bias continues, then we know this machine, even if we don't know how it made the decision, is making this same decision process for everybody. So if there's bias continuing after we have this result, then we can go fix it. We can go say, this isn't working, let's fine tune. So it's an optimistic advantage of machine learning.
It is, and I can kind of dovetail on that a little bit. In practice, one of the practices that we're now putting into place across several teams is a data set review process, where before we feed any kind of data set into a machine learning pipeline, Ed, to your point, the data set more or less has to be peer reviewed. And it's not just by human eyeballs, it's actually, we use other ML algorithms to determine the level of bias and tools and services. And from a very pragmatic standpoint, one tool that we use quite a bit is a tool called Clarify, and it's an AWS tool. It's part of their SageMaker set of tools. And Clarify's mission is to detect bias in data sets. And it uses a variety of metrics and data analysis and visualizations, and it kind of collects a whole variety of different ways that you can look at your data and get a very holistic viewpoint of what's going on there, and makes it very, I don't want to say simple because it's not simple, but it makes it very accessible to easily find out whether or not the data sets that you're working with have any kind of inherent bias in them. So we have a mandatory process that we put all of our data sets through, based on our awareness of the kinds of things that can go wrong that I was talking about earlier. Right. Kind of from a compliancy standpoint, we now have to do these kinds of reviews of our data sets that are going to be supplied to any kind of machine learning model.
Excellent, excellent. So I think Laura sent out in the chat, but I'll repeat it. Everybody's going to get promoted to the panelist role. All you got to do is click on the prompt on your screen and accept to join. And if you want to ask a question, just unmute and throw things out there. Maybe John, at Future Talk, you can kick us off.
Sorry guys, I just jumped in, so I missed the first like 20 minutes of this whole thing. But I know that like we've been doing some machine learning and education stuff. So I'm very curious about what you guys are talking about today, and what we're doing.
Do you want to talk a little bit about what you're doing? Feel free to self-promote.
Sure. Yeah. Okay. Great. I'd love that. So I run a education factual animation studio in Toronto, Canada, called Thought Cafe. And we also have a sister company called Future Talk that does immersive web development and WebXR stuff and some machine learning stuff. So Thought Cafe has a YouTube channel that some of you may be familiar with called Crash Course, which is a co-production that we're involved in. We do all the animation, branding. It's been on YouTube for about 9-10 years now. We have a significant following. Our courses, it's all high school curriculum, and the courses have been viewed, over 1.5 billion times. It's a very popular part of the YouTube education kind of lexicon. And what we've been doing over the last, couple of years is really trying to figure out, we've got about 1,600 episodes of AP curriculum high school content and we've got this giant library of graphic design based illustrations and motion graphics. And we kind of are trying to figure out, you know, how can we use machine learning to take that library, which hosts a ton of metadata and relationships between the scripting process and the videos themselves and the final animations and all the different software applications that we use, and create a system where we can like kind of smart query the library of, you know, 100,000 art assets and kind of like start to rough build out episodes and new animations just through machine learning itself. I hope that's clear to everyone what I'm referring to.
That sounds pretty cool. So other questions from the audience? I'd be very curious to hear other examples of how people hope to use machine learning at their organizations, and you know, how it's actually being applied in the ed tech corporate space, and like what customers, school districts, parents are actually purchasing.
I have a question in chat. The point about reviewing data sets is very interesting. I'm wondering how that works when the system is live, like new data is being created every second.
So in this particular system's case, the way that it works is that the data sets are done on a batch basis. So the model's trained in using batch data at a very deliberate interval. And inference is done in real time based on that data that it's been trained on. The bulk of the work and the upfront reviews are done in the initial training phases of the model. As new data comes in, we periodically review the batches, make sure that there's what we call model skew and data leakage and drift, where the new data starts to differ from the historical data, the data that the model was originally trained on. And that's actually part of the review process as well, because all the batch data sets that go in here, we make sure that drift is within a certain tolerance and that the gap between data coming in and the original training data is within a certain threshold. And a lot of that is, you would be surprised at how automated a lot of that actually is in terms of the actual pipeline that performs a lot of those activities. Because to do it at scale, if everybody's eyeballing data, it's very, very difficult. So a lot of it gets into the more ML operations, DevOps, engineering automation, and data engineering, and a lot of those aspects of an ML solution come more into play, more so than the model training and the actual kinds of algorithms that we use.
You got a reply, thanks. So I think you got it.
Cool.
So any other questions? I don't want to leave the audience out, but jump in, or I'm going to ask my own. The question I had for you that I wanted to cover, but we kind of skipped over, was AWS. What tools are available? Which ones do you like? Which ones need work? How is the Amazon stack supporting machine learning?
Right. So in general, AWS has a very comprehensive set of machine learning tools, and they're releasing more tools almost on a daily basis. A lot of my work, I work very, very closely with the internal engineers at Amazon in their ML space. And the big tool that I'm sure many here are familiar with that AWS provides for machine learning purposes is a tool called SageMaker. And SageMaker is actually a whole set and suite of tools that handle various different aspects of kind of what we call the machine learning life cycle or machine learning pipeline. And I mentioned one earlier, a tool that came out a year or two ago called Clarify, which is their SageMaker service for detecting bias in data. So that is a tool that we leverage quite a bit on our data sets. As a matter of fact, when we started the review and the compliance process in terms of making sure our data sets are fair and equitable, Clarify, the analysis that Clarify would do for us was and continues to be incredibly helpful for us. And what's nice is that a lot of what Clarify does and how it's used can be automated and incorporated into the other parts of SageMaker to develop and build a more comprehensive ML solution, starting from raw data ingestion that hasn't even been clean looked at, or any feature engineering hasn't been done, all the way to actually getting some kind of inference endpoint out in production that is scalable and fault redundant. You can pretty much build a pipeline like that entirely in SageMaker without having to leave it. Now, with that said, AWS also has much higher level services available, particularly in terms of video and image recognition, audio transcription, audio natural language processing, and things like that. So you have AWS Recognition, which handles image and video processing. You have AWS Comprehend, which is natural language processing. AWS Transcribe, which transcribes audio. So we use a lot of services that will transcribe various audio clips and then run that through Comprehend, which will do NLP, natural language processing, on the output of the transcriptions, and then we can use the output of Comprehend to do all sorts of various analysis and actionable things with. So they have quite a bit of services that can be leveraged by practitioners who have various degrees of knowledge in the data science space and with machine learning. You could use something like AWS Personalize to create a recommendation system. I honestly, with a couple of clicks, it's not really effort intensive, versus if you need to, you could actually work on a bare metal framework like TensorFlow or MXNet or any of the various ML or deep learning frameworks, and you can actually write the code yourself and take control of everything that you need to do without any of the services kind of, I don't want to say in the way, so to speak, but helping things along for you. So they have a very comprehensive set of tools for all varieties of machine learning maturity levels in different organizations.
Well, that kind of takes us to the end of the scheduled time. Laura, did you want to?
Sure. So I just want to let everybody know that's in the audience, we'll be sending out the recording for this session this evening. If you do have questions that come up afterwards, or maybe when you're reviewing the video again, please feel free to reach out to Phil or the JBS team. You can also reach out to me or Ed, and we'll be happy to get those answers to the questions that you have. Just want to thank everyone again for your time this evening, for our presenters, and for the audience who attended this evening. And hopefully we'll see you at the next one.
Thanks, guys. I really learned a lot.
Thanks so much.
Thank you.
Thanks, everybody.
Thanks a lot. Have a great night.